G'day everybody, and welcome to this video, the fifth video in this series on looking at linear relationships. And today we're looking at gradients and direct proportionality. So first things first, what does it mean if things are directly proportional? Well, we say if we've got two different variables, doesn't matter what they are, we say that they're directly proportional if their rate of change is constant. So the way that one changes according to the other, it is constant. So a constant gradient, and if we think about that as a graph, it's going to be a linear function, so a straight line. And the other thing to note about being directly proportional is that these lines pass through the origin, 0, 0. Because their gradient is constant, they all have the form, or the equation of the line is y equals mx. All right, so the y-intercept's obviously 0, and you guys have seen already that we've used y equals mx plus b. Because of that y-intercept 0, we end up just with this equation, y equals mx. And that makes life really easy to find the equations, because as soon as we have what the gradient is, or what the rate of change between those two variables is, we can easily find the equation of it. Now, don't be scared that we're using y and x here. These variables can be anything. And usually we choose our variables that are going to be something that's meaningful to the question. So if they're given something in terms of volume and time, as you'll see in an example later, we're probably going to use something that makes sense for that question. So we might use v for one of the pronumerals of volume. We might use t for the pronumeral of time. So what can we say? The gradient, as I said, is a constant. It's just it's a number. That's what we're looking for. So something like 3 or a half, you might have a decimal, 0.2, something like that. But the other thing is, when we have the gradient, in this context, we call it the constant of proportionality. All right, it's the constant of proportionality between those two variables. So let's have a look at an example here. Old mate Jerry starts to fill his empty petrol tanker at a constant rate, and it takes him 4 hours to fill the 8,000 litre tank. A few questions. What's the rate at which the petrol fills the tank? Then can we draw a graph of volume versus time, find the equation of the relationship between V and T, then use that equation to find these things. So you can have a go at it if you want to pause this video, or I can get stuck straight into how to do these. So the first one, what is the rate at which the petrol fills the tank? So when we're calculating rate, we're looking at amount that we've got over time. So obviously he's filling 8,000 litres. It takes him 4 hours, so we're simply going to go divide that 8,000 by 4, and that will give us 2,000 litres an hour. Now, something really useful when we're finding rates, our units actually tell us as well, not only what our calculation has been, but what, if you've got given a unit, you can find out where that's come from. So we can see here I've got 8,000 litres over 4 hours. As I simplify that to be 2,000, that's why we end up with litres per hour. And that's why we write our units like that. Question B, draw a graph of volume versus time. So now we know it's a linear relationship, it's a straight line, and that makes life really easy. The other thing is, because it's directly proportional, we know that it's going to pass through the origin. So if we simply find one other point on that line, and for this one we're obviously going to use the end point, we can easily graph that. So we're just going to construct, because we know that it's a positive values and it's directly proportional, we only need this top kind of section, what we call quadrant 1 of what we would call our Cartesian plane. And so that's why I've only used this section here, and I haven't bothered with my big crosshairs that goes both negative. So we can see it passes through the origin here. Our tank is full after 4 hours at 8,000, and that's why I haven't put an arrow on the end here to show it keeps going. All I've been told is that it goes to there. Obviously, if that's the capacity of the tank, then that's it. We can't go any further. So we're just going to stop our point there. We're not going to have an arrow on the end of this graph. Then we just want to make sure we put in our units. So obviously volume's on this axis instead of the y, and time is on the horizontal axis, which is t. Now some of you may be wondering, well, which one do I put where? Like, why have you put t down the bottom there? And that's just, we use what we call the independent variable, goes on the bottom axis, and often whenever we have time, that is going to be along this bottom axis. So the vast majority of the time, when you get a question that involves time, please put it on that horizontal axis. And then whatever the other variable is, we're going to put on that vertical axis. All right, so there's our graph there, just labeling there. I've chucked in an extra point there. You can see it halfway. As long as it's a straight line, you're looking good. So question C, find the equation of relationship between V and T. So what is the rule, the equation of V versus T. Like, what's going on? Well, as I've already said, the equation of a line is going to be in this form, y equals mx. Now, obviously, we've got V in here for y, and we've got T in here for x. So we're going to have something like V equals mt, all right? Where obviously m is the gradient or our rate, and we found that in the first one. We found that our rate was 2,000 litres an hour. So it's as simple as that. Our V equals 2,000 times T, all right? And that should hopefully make sense to you. Every hour, I'm getting an extra 2,000 litres into that tank. Question D. Let's use our equation now to find V after 3 hours and how long it'll take to fill 7,000 litres. So let's have a look at the first one. All we're doing is we're told that T equals 3. So we're going to use our equation that we've got, V equals 2,000 T, and we're going to put in T equals 3. So when T equals 3, V equals 2,000 times 3, which gives us 6,000 litres. All right, it's always good to explain what you're doing. So that's why I've written when T equals 3, not just throwing an answer in there as 6,000. You want to show whoever it is that's looking over your work, you understand what's going on, just to make sure that you're getting all your marks there. How long is it going to take to fill 7,000 litres? Well, this time we're just told that V equals 7,000. So we're going to substitute in V equals 7,000 into this one. And then we're solving for T. So here we'll just need to divide both sides by 2,000 by the coefficient of T. And we end up with 7,000 over 2,000, which obviously is a fraction, is 7 over 2. Or in this circumstance, because it's a nice pretty number, I've just left it as 3.5 hours or 3 hours and 30 minutes. Well done. Thanks for coming. I hope you understand it and you're happy to get amongst that now. See ya.